Hello dear students, today we start a new module that is chromatography, which is module number 3. In this video I will give only a brief introduction of what is chromatography. Chromatography is a very modern analytical technique used for separation, purification and characterization of chemical compounds or components in a mixture, both organic as well as inorganic compounds. It's a very advanced technique. It can be used for separating a large number of compounds in a very small trace quantity of a mixture, or it can be also used for separating natural compounds, natural products in bulk quantities like plant extracts, alkaloids, terpenoids, etc. Now today we discuss these things. First the introduction or the history, and then what is the underlying principle, general principle of chromatography, and then the classification. As a matter of fact, this technique was introduced by a botanist, Michael Twet, in 1906. He separated plant pigments like chlorophyll from plant extract, and he used a column of calcium carbonate and petroleum ether for the separation, and he got various colored zones. You know, plant pigments are obviously colored, and he got colored zones in the column. That's why the name chromatography. The term chroma means color. We have learned about chromophore in spectroscopy, right? So originally it is used for separating colored pigments. That's why the name. Now, what is the principle behind chromatography? It involves differential distribution of components in a mixture between two phases, that is a stationary phase and a mobile phase. So components in a mixture get distributed, get separated between two immiscible phases. Remember, stationary phase and mobile phase are immiscible. They will be immiscible. So the components get distributed. So it is the differential distribution of components over two phases or between two phases. One is stationary phase, we abbreviated SP, and mobile phase, that is MP. So two phases are involved in chromatography. This is to be noted. Stationary phase and mobile phase. So to understand the principle, we can consider one type of chromatography, that is column chromatography. So what is done is, we take a glass tube and in that we fill the stationary phase, which will be either a solid or a liquid held on an inert solid support. So stationary phase can be either solid or liquid. Okay, so it can be a solid substance like silica, alumina, etc., or it can be a liquid held on a solid support. A liquid alone cannot remain as a stationary phase, so then there will be a solid support, inert solid support like some resins, and liquid will be held on that solid. So we will have a stationary phase, which is either a solid or a liquid supported on a solid. So what we do is we apply the mixture which contain the components at the top. Right? This is a mixture which contain various components. So what happens? Various components in the mixture get absorbed or held on this column, stationary phase, to different extent, because different components will have different structure, different polarity, etc. So they will remain attached to this column to different extent. That means some components attached loosely, some components attached strongly. Now what we do, then comes the mobile phase. Mobile phase has to be either a liquid or a gas, because it has to be a fluid, right? So a liquid or a gas can be a mobile phase. So what is a mobile phase? The phase which percolate, moves over the stationary phase. What is a stationary phase? The phase which remain fixed, right? Which remain fixed either in the form of a column, or it can be like a thin layer applied on a plate. In different forms we carry out chromatography. Anyway, when we use the mobile phase, which is just simply a solvent, what happens when the mobile phase trickles down over the stationary phase, the components get separated. How? The one which is weakly interacting with the stationary phase will move faster and comes out first. The one which is strongly interacting with the solid phase, stationary phase, will come slower or slowly, and it comes out last. So in that way the components get separated. So that's the basic principle of chromatography. Differential distribution of components in a mixture between two immiscible phases, stationary phase and mobile phase. The component which is strongly held will move slower and comes last. The component which is loosely interacting will move faster and comes first. That way the components get separated. Fine. Now coming to the classification. There are different types of chromatography. Basically, generally they can be divided in three different ways, three types of classification. See the first one. The first classification is based on the mobile phase used. I told you mobile phase can be liquid or gas. Okay. So based on the type of mobile phase, the nature of mobile phase, there are two types of chromatography. If it is liquid, it is called liquid chromatography or gas chromatography. Now this is again divided based on now the type of stationary phase used, based on the stationary phase, which can be either solid or liquid held on solid. So naturally there are two types, that is liquid solid chromatography. See, when we write the abbreviations of chromatography, we write the mobile phase first. Okay, so liquid, because it's a liquid chromatography, solid chromatography, and liquid chromatography. Here this is the stationary phase and this is the stationary phase here. And the second one is gas chromatography, is again of two types. Similarly, based on the type of stationary phase, if it is solid, it is gas solid chromatography. If it is liquid, gas liquid chromatography. Now coming to the second classification, it is based on the mechanism of phase distribution. How the components get distributed in the stationary phase. What is the phenomena taking place? According to this, there are two types of chromatography. One is adsorption chromatography, where the distribution, the separation is due to the differential adsorption of the components on the stationary phase. That is called adsorption chromatography. So this term comes from the type of mechanism involved. So it is the adsorption which is involved here. For adsorption, naturally the stationary phase has to be solid, isn't it? So that's why liquid solid chromatography and gas solid chromatography come under adsorption chromatography. Whereas in partition chromatography, the mechanism of phase distribution is partitioning, right? So in that, the tertiary phase has to be liquid. That means liquid held on a inert solid support. So it can be of two. That is liquid chromatography and gas liquid chromatography. So between two liquids which are immiscible, there occurs what is called partitioning. You might have learned about partitioning or distribution, where Nernst law is associated with this distribution. That means, suppose for example, to understand what is partitioning, in water you put some benzoic acid, okay, in which it is only partially soluble, to which you add benzene, another liquid. What happens? Benzoic acid, which is more soluble in benzene, will move to the benzene layer more from water. Only very little amount of benzoic acid will remain in water, more will go to benzene. That is distribution or partitioning. So partition chromatography is based on differential partitioning of components between two liquids. Fine. Now the last type of classification is based on the operational technique. That means how we carry out the process, the method. One is column chromatography. That is what I explained at the beginning. In column chromatography, how we take the tertiary phase? It is in the form of a column. We take a column of the tertiary phase is taken in the form of a column, right, as a solid, or it can be liquid. Then we take an inert solid and we take the liquid in that. So it is taken in the form of a column, right? So it can be an adsorption column chromatography or a partition column chromatography based on whether the tertiary phase is solid or liquid. Then the second one is planar chromatography, where the tertiary phase is taken in a planar form, right? It can be also called a two-dimensional chromatography, which is again of two types. One is paper chromatography. This is a very simple kind of chromatography which we can do our own, or we can do in the lab. That is, we take a strip of paper, a filter paper or a paper of chromatographic grade. So it's a planar chromatography, and in the case of a filter paper, cellulose. The filter paper consists of cellulose of high quality here, and it will definitely contain water molecules in that. So in paper chromatography, it is a water, the liquid which is held on a solid, act as the tertiary phase. In thin layer chromatography, what we do is we take a glass plate, glass slide, or you take a plastic sheet or an aluminum foil in this form, right? And we apply a thin layer of the tertiary phase. For example, we make a paste of silica gel, silica powder, and we make a paste on it and dry it out and use as the tertiary phase. In column chromatography, the difference is that here the mobile phase is applied here at the top and it comes down generally. So mobile phase moves down under gravity, or sometimes we apply pressure for a faster separation. So under gravity or under pressure, mobile phase moves down. Whereas in planar chromatography, generally we apply the sample over here. So sample is applied here, and it is kept as in some jar, and we take the mobile phase at the bottom. We add mobile phase here and we keep it closed. What happens here is that the mobile phase will move up. Here it happens due to what is known as capillary rise. Okay, sometimes it's done the other way also, that is somehow we keep some trays over here and keep the mobile phase, and it comes down also under gravity. So mobile phase may move under gravity if it is top to bottom, or in more occasions it is from bottom to top, moves up under capillary action. So these are all, and this thin layer chromatography is very common, that's called TLC. Now in coming classes we discuss in detail about different types of chromatography. In our syllabus we have to discuss in detail about adsorption chromatography and partition chromatography, then specifically about paper chromatography, thin layer chromatography, and finally about gas chromatography. Okay, in coming classes. Till then, bye.